Picking the right CPU in 2025 feels like navigating a minefield. Hybrid cores, 3D V-cache, NPUs. What on earth do all these marketing terms actually mean for you? If you've ever felt overwhelmed by spec sheets and jargon, you're in the right place. By the end of this video, you'll know exactly what to look for, whether you're building a gaming beast, a creative workstation, or just a reliable daily driver. Let's demystify the brain of your computer and make sure you get the perfect processor for your needs and budget. First, let's talk about the fundamental building blocks: CPU architectures. For decades, the battle has been dominated by x86, the architecture behind Intel and AMD processors. It's the king of desktops and high-performance laptops, offering unparalleled compatibility with games and professional software. But the landscape is shifting. ARM, the architecture that powers your smartphone, is making huge waves in the laptop space with incredible efficiency. Think long battery life and fanless designs, like Apple's M-series chips. And keep an eye on the horizon for RISC-V, an open-source alternative that's gaining traction in developer boards and specialized devices. So, for raw desktop power and gaming, x86 is still your best bet. For a laptop where battery life is everything, ARM is a compelling choice. Now, let's dive into the core of the matter, literally. You've probably seen CPUs advertised with a certain number of cores and threads, but now we have P-cores and E-cores. What's the deal? P-cores, or performance cores, are the heavy lifters. They run at high clock speeds and are designed to tackle demanding, single-threaded tasks like gaming or running complex calculations. E-cores, or efficiency cores, are smaller, use less power, and are perfect for handling background tasks or multi-threaded workloads. Think of it like a team. The P-cores are your star players, while the E-cores are the reliable support staff handling everything else so the stars can shine. For most users, a hybrid design with a good mix of both offers the best balance of performance and efficiency. Extra threads, thanks to technologies like hyper-threading, allow each core to handle 2 tasks at once, which is a massive boost for video editing, 3D rendering, and even modern games. Next up is cache, the CPU's secret weapon for speed. Think of cache as super-fast, on-chip memory. When your CPU needs data, it first checks its L1 cache, then L2, then L3. Each level is bigger but slightly slower than the last. If it finds the data there, a cache hit, it's lightning fast. If not, it has to go all the way out to your system's main RAM, which is significantly slower. This is why a large L3 cache, or specialized tech like AMD's 3D V-cache, can make a huge difference in gaming, smoothing out frame times and boosting your 1% lows for a stutter-free experience. Speaking of RAM, we're now in the era of DDR5 with DDR6 on the horizon. Faster memory means the CPU spends less time waiting for data, further improving overall system responsiveness. So don't just look at core count. A CPU with a giant cache can often outperform one with more cores but less cache in certain tasks. Let's talk about power and speed. You'll see boost clocks advertised, like 5 GHz or more. This is the maximum speed a core can reach for a short burst. But what really matters is sustained performance, and that's all about the power budget, measured in watts. A CPU might be able to hit a high clock speed for a second, but if it generates too much heat, it will quickly throttle down to a lower speed to stay within its thermal limits. This is why cooling is so important. A better cooler allows the CPU to sustain its boost for longer, giving you more performance. Many CPUs also have eco modes, which limit the power draw. This is fantastic for saving energy, reducing heat and fan noise when you're just browsing the web or watching videos, but you'll want to unleash the full power for demanding tasks. One of the newest and most talked about features is the NPU, or Neural Processing Unit. This is a dedicated accelerator designed specifically for AI tasks. In 2025, this is becoming more important than ever. What does it actually do for you? It powers features like real-time background blur and noise cancellation on video calls, making you look and sound more professional without bogging down your main CPU cores. It can automatically organize your photos, provide instant language translation, and even help with AI-powered features within creative apps. By offloading these tasks to the NPU, your P-cores and E-cores are free to focus on what you're actively doing, leading to a snappier, more responsive system. It's all about smart, efficient computing. So, how do you match all this tech to what you actually do? Let's break it down by workload. For gamers, the most important metrics are high single-core performance from those P-cores and a large cache. This combination is key to achieving high frame rates and, more importantly, consistent frame times, which means eliminating those annoying stutters and dips. For content creators, video editors, graphic designers, 3D artists, a high core and thread count is paramount. More cores mean faster video exports, quicker render previews, and smoother multitasking between heavy applications. For coders and developers, it's a mix. Fast single-core speed helps with code execution, while a high core count dramatically speeds up compile times, letting you get back to work faster after making a change. Now, let's translate this into buying advice. We can break it down into 4 tiers. The good, or budget tier, is for everyday use and light gaming. Here, you're looking for a solid 6-core processor that offers great value. The better, or mid-range tier, is the sweet spot for most people, especially gamers. This is where you'll find CPUs with a great mix of P-cores and E-cores and a healthy amount of cache, delivering fantastic performance without breaking the bank. The best, or high-end tier, is for enthusiasts and creators who want top-tier performance. These CPUs pack the highest core counts, fastest clock speeds, and largest caches available in a consumer platform. Finally, the workstation tier is for professionals who need the absolute maximum core count for tasks like scientific simulation or high-end VFX rendering. These processors are in a class of their own, with a price tag to match. So, what does the future hold, and what's your final checklist before you click Buy? The trend is clear. CPUs will become even more hybrid, with potentially more types of specialized cores beyond just P and E. Caches will continue to grow, and NPUs will become standard, handling more intelligent background tasks. Your checklist for 2025 should look like this. First, identify your primary workload: gaming, creating, or general use. Second, set your budget and look at the best options in that tier. Third, pay attention to the core configuration. Do you need more P-cores for speed or more total cores for multitasking? Fourth, don't ignore the cache size, especially for gaming. And finally, consider the platform. Make sure your motherboard and RAM are a good match for your new CPU to unlock its full potential. Choosing a CPU doesn't have to be complicated. By understanding these key concepts, you are now equipped to make an informed decision and build a system that's perfectly tailored to you. Thanks so much for watching. If this guide helped you out, a like would be amazing, and consider subscribing for more tech deep dives. Let me know in the comments which CPU you're planning to get. Catch you in the next one.